Hello guys, this is Craft the Game and today we are here for the episode 6 of the 𝗦𝗢𝗘𝗙𝗦 series. Yes, it's been a long time, I didn't post a video, but this is the day. I'm back, guys. Okay, so as we did in the last video, we got the brown tank here who is not moving. So as you can see, it can shoot us, it gives the damage, and then we can kill them. But before going deep into the dev, we're gonna make the world a little bit prettier. So as you can see, I got some VFX for my bullets. Let me know if you want some VFX tutorials. Let's make a good ground. So let's go into the graphism environment and let's create a folder called ground. Into it, let's create a material. Let's call it m_ground. Drag and drop onto the ground. Into the Google Drive, you're gonna find 4 texture. Drag and drop into Unreal Engine and then open the material. Drag and drop here. So first, into the meltness, put 0.1 and 0.8. We want that the texture is world tiling. So search for world aligned and you can see you have some texture and search for normal. Here, as you can see, we cannot drop because it's float 3 and not compatible with texture 2D. To put this, right click the texture and convert to texture object. So now you can drag and drop. Do the same for the normal, drag and drop, and put the X, Y, Z texture onto the good nodes. So like this. Now, as you can see, we have good tiling about the world. So if I move the plane, the texture is not even moving. But I think this is too little, like the tile is too high. So let's create a constant, convert to parameter, and call it world tile. As you can see, this is here, texture size, 64 for 64. We want that it's, I think, 128, so put it into the texture size. As you can see, this is more tile and better in the game. Do the same for the ambient occlusion and the specular with a world align texture. And now it looks great. Now let's go into the dev. Now let's fix some issue that appear on the last episodes. Now go into tank enemy master. Into the scope trace test, there is only tank tag. So to fix that, we're gonna create another tag. Let's create enemy tag. We're gonna put a verification after the tank because enemy are already just a tank. So let's take this, drag and drop the bounce more on the right, and into the true of the tank, we put a branch. Here, let's copy paste the actor as tag, and then let's copy paste the tag. Be sure that it's exactly the same name, caps included. So, is it a tank? Yes. Is it an enemy? Yes, so don't shoot. But if it's not an enemy, this is a tank. So check the should shoot. Now we have the bounce. And then we have to make the same condition into the bounce. So there, put it more on the right. If it's a tank, put the branch on it. Make sure to drag and drop it actor on actor as tag. This, let's put the false here. And then, if it's not enemy, it should shoot or it should not shoot. And voila, this is fixed. So now we're gonna be comfortable to create the hash tank. So let's right click into the tank enemy master and create child blueprint. Call it pp tank hash. So as we can see here, hash appear on the mission 2, have slow movement, bullet speed normal, so we don't need to create another projectile blueprint. We're gonna use the same as the player and the brown enemy. You have a slow fire rate, so this is the same as the brown enemy. Have 1 ricochet, 1 max bullet, but as we can see, he is defensive. So let's put the variables into the hash tank BP. So double click into BP tank hash. So, you have normal life. Projectile to shoot is the normal one, bullet count he have only 1, mine count 0. Is the hash tank have a perfect precision for now. For the test, we're gonna keep the 0, so the line trace gonna be all the time perfectly on the player. I mean, we're gonna put 3 to have 100. His movement is slow, have a defensive behavior. He can bounce and have a bounce count max of 1, and then we don't touch about this. So now, as we can see, we have nothing into the BP because everything is controlled into the tank enemy master. Let's just put precision rate to 0.5. So now we have to create the defensive behavior and the movement. So let's close the 10 cache, and now we're gonna see together how we're gonna code the behavior. So let's do this into mirror. Here we're gonna have the tank hash. Our tank gonna have 2 separated phases. He will try to chase and get a kill when he can shoot, so when he have some bullets, or when he have no bullets, he gonna try to retreat or just hide. So let's create 2 cases with chase and retreat. Let's begin with the retreat mode. The retreat mode is quite simple because we just want to have the condition if he has bullets. If he has bullets, he don't have to retreat, so he have to go back into the chase mode. But if he has no bullets, he have to retreat. So now he gonna do the retreat sequence. Here, get a hide position from player. Then we will want that to move to this position. Let's mark the text as yellow for position to remember it. So position gonna be a variable. Then when we have achieved the move position, we want to check again if he has bullets. But before, we're gonna put a wait of 0.5 seconds. Then when this loop is done, we want to go back into the has bullet condition. So to understand better, we're gonna do like this. Then let's go back into the has bullet condition. This is our retreat mode. We're gonna put the chase mode more into the left, and then into the chase mode, we have 2 conditions. We don't want that the tank just chase and go into the player like it is a melee enemy. This is a distance enemy, so we want to get a position with a good distance and a good line of sight to be able to shoot into the player when he's still hiding. So to do this, we have a shoot sequence and a get line of sight sequence. This gonna be a condition if we can shoot on the player because there is a line of sight. If not, you're gonna always get a position of line of sight. Let's do this. It's gonna be easier to understand. Is the target in line of sight? If yes, we just want to do the shoot sequence as we did here. If yes, we want to do the chase selector because here is gonna be selector. Here, if there is no line of sight, we simply want to do the same as we did here. Get a good position, move to the position, and then wait. So we check if there is line of sight. We're gonna get a line of sight position to shoot player. Here we put the player, but it's basically the target. Then after this, we just want to move to the position as we did. And then again, we just want to wait 0.5 seconds. Now we want to check again if the line of sight is pretty good. So now we're gonna make this loop again and again if we don't get line of sight. Okay, so now let's do the shoot sequence. Into the shoot sequence, we want to check the line of sight because if there is no line of sight, we want to go back to get a line of sight. This is just what we want to do. And then if we have a line of sight, we're gonna make the shoot sequence. The shoot sequence is pretty simple, but let's add some difficulty on our AI. We want that is moving all the time, like strafing behind walls, etc. So we want to first, if we have a line of sight, we just want to shoot. So look at target. The target is the player. Here, do the attack of tank. So here is the shoot projectile. With the look at target, the tank gonna be aligned with the target. So if we just shoot a projectile, this projectile will go directly into the target. Here, let's put a little weight of 0.5 seconds. And then we just want to check again if there is a line of sight. So let's put it like this. So If there is no line of sight, we just want to wait again 0.25 seconds and put it back into the line of sight condition of the shoot sequence. So if it's not, it will be not, and then gonna go back into the get line of sight sequence. If it's yes, we want to first get a position for strafe, we move to the position, and then we go back into the wait 0.25 seconds. So now, guys, we have the 𝗥𝗘𝗙𝗘𝗦. So now, let's do this into Unreal Engine. Into the enemies folder, let's create a folder called AI. Into the AI folder, we will create a blueprint class, search for AI controller, and then click on AI controller. Click select and call it AIC_enemy_base. This gonna be our new AI controller for all the tank. Then we will need into artificial intelligence a behavior tree. Click on it, create BT for behavior tree _enemy base. Then go back into artificial intelligence, create a blackboard, BB for blackboard, enemy _base. Now let's open our behavior tree. As you can see here, when you click on the root, you're gonna have access to the blackboard asset. Normally, if you create before the behavior tree and then the blackboard, it's gonna set by default the good blackboard. If it's not, just click and select the good one. Now, if you go to blackboard here, it's gonna open the good blackboard. Into our root, we're gonna make our selector, which gonna swap into two other selector. This selector, we can call it check if have bullet. This is our condition if it chase or retreat. Here, let's put another selector and call it chase. Here, selector and call it retreat. Then create a sequence into the chase mode. This sequence is get line of sight and create another sequence called shoot target. Into retreat, we just have one sequence for now, and then we want to call it retreat target. Why retreat target? Because it just wants to hide from the target. In the future, we're gonna enhance the AI, so it's gonna retreat from the mine. So we have to specify a retreat from the target. Now, as you can see, we can create new task and new decorator. So we're gonna create some folder to separate all the things. Now, let's go into the blackboard and create some variables. The blackboard variables gonna be a certain way for the AI to have like local variables for him, and then he gonna pick sometimes when we gonna call it into the BP enemy master. Create a new key of type object and call it target. Then, as we seen into the Matheo, we want a vector node. Now you understand the yellow color. So let's rename as destination. Now let's go back into the behavior tree. Here gonna be a selector. A selector is working like if he can go here, he gonna still go here, because into the behavior tree, everything is doing the left to the right. But if this selector can go here, he will always go this way. So we need a condition that's make, okay, can I go here? If not, I go retreat. And this is what? This condition is the check if the enemy tank have bullet. But if you remember, we don't have Boolean condition that can tell us if the enemy have bullet. So let's create it. Create a new variable and call it have bullet. Now let's move it up. And then we want to create a function that's gonna tell us if the enemy have bullet. So call it check if have bullet. Drag and drop here and check into the event tick if you have bullet. For now, we're gonna put into the event tick, we're gonna optimize it later. Now, into it, take your Boolean condition, press Alt to set directly, and then here, we just want to know if the bullet count is less than bullet count max. So this will tell us if you have bullet. Now we want to get the variables here. To create a condition, we just need a decorator. Click BT decorator blueprint base, go into the decorator folder and call it btd have bullet on load. Save it, and then into the function, we're gonna override the perform condition check AI. As you can see, we can return a bool value. Here, we want to cast the enemy master and then get the have bullet condition, which is updated into the event tick. Now we have our decorator. So we're gonna put the decorator into the chase and into the retreat. Let's put the decorator to make the condition. right click into the chase selector, add decorator, and here you have btd have bullet onload. And then when the selector is here, you're gonna continue to make this. So we need the same condition, but this time reverted. So check the inverse condition. Now we have good condition to know where to go. Now we did it on Unreal Engine and we can see that here there is a problem because we don't have as bullet condition into the chase. So it will never go out of the chase. Copy paste the as bullets. And then, if we have bullets, we go into the get line of sight. If not, we want to go to retreat. Now, we need to make another decorator with the blueprint base into here and call it is target line of sight. Let's save it, override the check AI here. We want to cast enemy master again, and then we don't have condition. So let's go back into the tank enemy master and into the scope trace test, which is our line of sight detection. We're gonna set the value should shoot as a variable. So let's promote to variable and call it is target in line of sight. Let's put it like this. Put it on the right and then put it like this. We will see it later, but all of this gonna be erased because this is automatically shooting. This is not controlled by AI, so we don't want it. Now let's go back into the target line of sight and get the line of sight condition, put it into the return as we did for the have bullet. You can close it now. Into the get line of sight, we want a decorator, so it will make the condition for us. If there is no line of sight, get a line of sight. But if yes, go into other. As we can see, into our behavior tree, we just get if the target is line of sight. So we have to inverse condition. So now there is line of sight? No. So revert. Now we want to make the same condition into here, but not inverse this time. Now we are good with the condition, even if we didn't make the strafe mode. We're gonna do it in the end. Then we're gonna create some function. As you can see, there is no function node. So we need to create into behavior tree. This is called task. Into the new task, now create new task, go into task, and then btt underscore clear focus. This is gonna be our stop look at the target. Now into it, call the event execute AI. Make sure to get the AI node. Here, we want to call clear focus. This, and then finish execute. Make sure to set the success boolean to true here. Now, let's go into the task and let's duplicate it and call it focus target. Into the focus target, let's keep just the execute AI and call the function set focus. Then finish execute and check success. As you can see, we need to put a new focus. So let's search for get blackboard value as actor. Promote it to variable and call it target key. Why target key? This is because our entry name here into the blackboard is target. But at this time, the value of the blackboard is not even set. So we don't have target into the variable. So now let's go into our AI controller. We can delete begin play and event tick and search for on possess. Then we need to reference our behavior tree and our blackboard. So here you can search for run behavior tree. Here search for enemy base. Now the behavior tree is good. We need to get the blackboard to set the value. So you can search for get blackboard. Make sure to get the variables here. The variable is gonna be set defaultly by the run behavior tree because, as you can see into the behavior tree, the blackboard asset is already set. Well, here we just want to set a value now. A value as objects because here this is type of object. Let's put it here, and as you can see, there is a key name and an object value. Object value gonna be the variable set it. So this is gonna be, for now, get player character. But here, we want to get a key name. The key name is exactly this, the entry name. So take all the characters, copy and paste it into the variables. So right click onto the key name, promote to variable, call it target underscore key name, and here compile and save and paste the entry name you got from your Blackboard. And voila, we set our variable with the get player character. Here, let's put just a little security because sometimes it can happen when the enemy spawn, there is some latence. So we can put a little delay of 0.2, 0.1. This is just for security. We have done with our AI controller. Now, the focus target, when you're gonna get target key, gonna focus into the good actor reference. Now, guys, we want to create a function that's able the AI to call the shoot function. So create a new task, blueprint base, into the task folder, and call it default shoot. Into the default shoot, execute AI, again, cast to enemy master. You should ask why sometimes I take the owner controller and the control pawn. This is because the pawn object reference gonna be the tank enemy master, and the AI controller object reference gonna be the enemy base. The enemy base gonna be implemented into the pawn here. That's why when we are here, we should get AI controller. This node is exactly the same as this one. But here we want to get the pawn, not the controller. Here we want to call the function shoot. Shoot is what? Is this function. Shoot gonna check if he can shoot, so if he have bullets. If he have bullet, he gonna bullet count more. Well, this is our attack function. Then let's finish execute with success. But with this technique, we're gonna have some issue. We need to know if the shoot sequence, so all of this, are done. Because if he can shoot, the animation gonna replay instantly, so it's gonna be buggy. So to don't have this bug, we need to create an event dispatcher. What is an event dispatcher? So into the tank enemy master, we want to create an event dispatcher. Let's call it finished shooting. Here, let's drag and drop and make a call function. So there we want to, when it's completed or interrupted, call the finish shooting. However, if he cannot shoot, we want to put security delay of 0.3 and put it into the call finished shooting. Now, when the shoot action is done, we will have all the time a feedback if the shoot just finished. The shoot finished, not even when the projectile is shot, but when the animation of the cannon, like this, is finished. So now we can go into the default shoot, and now we want to finish the execute of the default shoot task only when the shoot is finished. So when the call event is called. So we want to bind event to finished shooting, like this, and then create a custom event. Let's call it just finished shooting, and put the custom event into the finish execute. So now, when it receives the execute, it's gonna cast and shoot, and then wait here to get a call if the shoot is finished. When the finish shooting event dispatcher is called, it's gonna unlock the bind events, so the custom event will finish execute. And voila, we got our default shoot function. Now let's implement it into our behavior tree. Let's begin with the retreat target. When we want to retreat, we don't want to look at the player or the target. So we want to clear focus. Then we want to get a position, like we said here, and move to this position. For now, we're gonna get all the position in a minute. So for now, let's just put a wait of 1 second. Now we want to move to a position. Remember, into our Blackboard, we created a destination vector variable. So here, we can tell to the move to function here the destination key. Destination key is a vector, so it's gonna be good. So now it's gonna move to the good destination. The destination gonna always be set by the get hide position, the get a position for strafe, a line of sight position, etc. Then we want to wait 0.5 seconds. Remember, this gonna be the get position. We just put a wait because we're gonna make it after. Now let's make the chase function. Here we want to focus target because we want to look at the target to get the line of sight. We want to get the position. Remember, we just put the weights because we're gonna make it later. Here we want to move to the destination of the blackboard. Then we want to wait 0.5 seconds. We have our get line of sight function. Now, when we want to shoot, we want to clear the focus and then focus again the target. After focusing the target, we want to shoot. So call the BTT default. Then we want to wait 0.25 seconds and then we want to make a sequence called strafe. Remember, here, when we want to know if we have to strafe or not, this is just our condition is line of sight. So here, at decorator is target line of sight. So if it's target line of sight, we want to get the strafe position and move to the destination set by the get position node. Now we want to wait 0.25. So now into our shoot target, it's gonna make this, and this all the time it enter into the shoot target. Now, depend on if we have a line of sight, we're gonna strafe, so get a position and move to this position, and then we're gonna wait again. If we have not line of sight, we're gonna just wait, so this plus this gonna make 0.5. So it's good. Now we just need to create the get position node. But before this, we're gonna implement our AI controller into the tank enemy master. So go into BPA tank enemy master, click on the root and search for AIC. You're gonna get AI controller class and search for AIC enemy base. Now our tank have the good AI controller, but as you can see, we don't have nav mesh. So here, search for nav mesh bounce value. Put it onto 0, scale it up like this, and you can press P to see the projection. As you can see, sometimes there is those things. We just want to scale down into the Z so it don't go above the crates. Before creating the get position, make sure to make the max wall speed by default at 200 centimeters. Remember to uncheck the branch and the boolean condition because this is not useful for now. But let's not delete for now because as you can imagine, tank enemy master control to the brown enemy tank. But brown enemy tank is not even moving, it's not doing all this behavior tree. Even if at this moment the AI enemy base is in tank enemy master and have only enemy base behavior tree. So we're gonna make a variant behavior tree, really more simple, for the enemy brown. So here, depend on our enemy master behavior, we're gonna make a switch that run the good behavior and set the good value. But let's do it at the end. Okay guys, now we're gonna create the get position function. So go into AI folder and create a new folder called EQS. Into the EQS is environment query system. You can go in artificial intelligence and create one, and let's call it EQS chase. Our EQS gonna be the get position. So we're gonna have a EQS strafe, EQS chase, and a EQS retreat. So into the EQS, as you can see, this is like a behavior tree. This is a root, so we can drag and drop. We have composite. Here we don't have composite, we have generator. Each generator gonna create some sphere, some position, some location, an array of location around an actor with a certain shape. For this one, circle, cone, donut, grid, and passing grid. To explain what's gonna happen, this is our player, and if we select point into circle, it's gonna make a circle, gonna set some points into the circle. Like this, into all the circle. Imagine this is a torus, this is gonna put some point here. For a grid, this is gonna make a grid, like this, and gonna put point in each grid. Grid system, grid generator is the good one, because if you remember, each box, this is a cube of 1 meter, 100 units. So there, we want to generate a grid, point grid. As you can see here, we can set a radius, so let's put for example 800, and a space between. Space between gonna be the space between each point. For example, let's keep 100. What size we want to set because we don't have feedback. So to be able to test, there is a method. You can search for EQS, and in 𝗥𝗘𝗙𝗘𝗦𝗧 we have EQS testing pawn. We can select it. We don't care about the name. We can keep blueprint. We're gonna erase it later. We can drag and drop in scene, and then here into EQS, select EQS chase. So as you can see, the grid is only generating into the navigation. This is because into the trace mode we have generation. As you can see, the EQS is generating around the pawn, because imagine this should be the enemy 10. But for us, we want to generate the grid around the player. So we need to create a context. Create a blueprint class, search for context, and here create a blueprint base and call it EQS underscore context underscore target. Now into it, we want to override the function provide single actor. So the query actor is get AI controller. Let's cast to AAC enemy base, and with this we're gonna get the attack target. So let's get Blackboard, get value as object, and the key name is make literal target. This is a way to do it, but I think for the moment we're gonna just get the player character and promote it to variable and call it target ref. So with this we can just get target ref. This is much easier and more clean for the context. So now into the EQS chase, we can go for context and get EQS context target. Now, as you can see, this is not even generating. Why? Because into AIC, we set the value here only on possess. But this is not possess on editor. We need to play to see. So the other way is really simple. Just to get actor of class, get back the return node, and search for player start. Drag this here, and now if we move, we can see it's generating around the player start, even if I move it. But if I move the player start and go back into the blueprint of context, and I move it, this is generating around the player start, because the grid should be like this. So now we know that we generate good position around the player. Now we need to create some condition to add some score to the EQS. You will see it's really simple. Let's put the player start here, so it's hide behind the box, and let's put our test just over here into the grid. Into the EQS, we can add some tests. We can test a lot of things, but the first thing that we're gonna do is pathfinding, because we don't want to generate the grid if the player is not even pathfinding, is not even reachable. So pathfinding will gonna filter this. As you can see, now we have some score of 1. But what we want is not even the score, it's just a filter. So now, as you can see, there is 0. So now if we create a zone not reachable for the pawn, it will not take it, as you can see. And now we just want to make sure that this querer is also doing the context around the target. Now, after our EQS test, we want to establish some score about the distance. So now if I go here, as you can see, everything is blue, but we just want to have score. So into distance to mirror, let's check score only. As you can see, around the pawn, the score is bad, and far from the pawn, this is higher score. This is not depending of the target, but on the pawn. But you should notice that we want to revert that. If the point is really far, we want the score bad, and then the closest is the point, the higher is the score, because the score gonna establish which point gonna be choose. Well, here there is 2 methods. We can scoring factor -1, so it will revert, but this is not a beautiful way, because into scoring equation, final score equals scoring factor multiply the normalized item value, we can inverse linear. We have revert the score. So now, the pawn, when you will select the point, he will prefer the green one compared to the red one there. Now, after this, if we take the pawn and put it around the player, as you can see, he thinks this position is pretty good. But this is the worst, because we are around the player. He can shoot us really easy. So, into the EQS, we have to get another distance test, but this time, distance to target. Now, if we check, we have the filter 2, but what we want is just to, around the target, get the minimum of 350 units. So now, around the player, this is not a good position. So if he's stuck to the player, he will always try to go far. If he is here, as you can see, the blue point still around the player. But now, as you can see, with this distance, those points and those points, when he is like there, those points are pretty good, but this is not the better. So we can increase the scoring factor of the previous distance check here by 2. Now we have our distance preference. So you will prefer to go to the highest score, so here, etc. But from here, for example, he can't even shoot into the player. So now we have to check if he can shoot to the player. So for this, we can add a test called trace. The trace is gonna be around the target to uncheck bull match. Now, depend of where is the pawn, it's gonna tell us what distance is the better. So you're gonna prefer those one as those one. So now we can see that if he's, for example, here, he can see the player start because the trace channel is good. So now we have our EQS chase. We're gonna do the EQS strafe and EQS retreat after. There, the get position, we can delete this one because the chase EQS gonna be called here. Now you can right click and search for EQS. There is EQS carry. You can drag and drop here between the focus target and the move to. I just saw that we forgot to set the focus target variable. So into the focus target, double click and check the eye of the target key we set it here. So compile and save, go back into the behavior tree. And now into the right, we have target key. Target key is the target. Be sure to set this to each focus target node. The clear focus target is not needed because we just clear focus. Well, let's go back into the query. We can select EQS chase. From here, we have run mode. Determines which item will be stored. So in our case, we can take 25% for the chase. Into the backboard key, this is where the point vector gonna be set. So as we said, we want to put it into the destination. So now, if we go back to the context and put back the enemy base target, so this is the player, and then we play, we're gonna try to go into a point to be able to shoot at the enemy. Now we will go fast to create the EQS retreat and the EQS strafe. So go here, environment query, EQS retreat. I created a simple grid as before with 800 half size, space between 100, and I generate around the target. I traced mode from navigation like all the time. I put a pass existing filter only around the target with a pass from context and the bull match as true. Here I create a distance to querer with a test purpose of filter and score, a distance to the querer, and a filter type of range between 150 and 600. And here, into the scoring equation, I inverse linear. Into here, I put a distance with a score only test purpose and a distance to target. Here I keep the linear, but I scoring factor by 5. And at the last position, I create a test of trace, a test purpose with a filter only, a geometry by channel, trace channel visibility, and trace shape line. This is everything default, but the context is around the target this time. The bull match check, so when the player and the querer can see each other, the points are not selected. So now, if the player is, for example, here, and the enemy just here, the worst point should be here and the best point should be here, because it will always select around the enemy to don't go too far and risk to cross the player. If he's there, for example, the worst point is the closest of the player, so he will stay here in this corner. If he is close to the player, every point is pretty good, even if there is close to the player. And then if he is on the player, he can go everywhere around if the trace test is false. So we are good with the retreat. Now let's create the strafe EQS. So we want a simple grid of 400 half size and space between of 50 around the 𝗥𝗘𝗙𝗦, because this is the enemy gonna strafe around. So we want to detect destination position around the enemy. We add a pathfinding test. This is test purpose filter only with a context of target with path from the context and a true bool match. Then we add a trace test with filter only, a context around the target and a false bool match. Now into the distance, we want a filter and score. We want to check the distance to the target with a filter of minimum of 150. So with a filter type minimum and a float value at 100, we want that the scoring equation is linear with a normalization type at absolute. Then into the force distance, we want to test purpose score only around the target with a scoring equation linear but a normalization type relative to score. And finally, we want a distance test purpose with filter and score around the 𝗥𝗘𝗦𝗦𝗢𝗡. The filter type is a range between 80 and 260. We want a clumping with no minimum but a maximum specified value at 0, a scoring equation linear, and a normalization type absolute. And then, if we test it, you can see generating the grid around the pound. You have before to do the chase mode, but if you do the chase mode and then he is on a good way, he will do the strafe. And then the strafe will indicate to go here, in this lot of points. This lot of points presents into the green zone of the chase. The strafe is more precise to make more little movement. If he is close to the player, he will try to go far. Well, now guys, we have all of our EQS. Now let's implement it. Into the get position here, we want to run EQS, an EQS strafe, because this is a strafe, and set it to the destination. We just want the best 5%, so it keep going around it. You can put 25% if you want. So you can delete the weight and put the run EQS here. Here, move the weight, add run EQS, search for retreat, and then we want to get the best 25% because retreat is always good, and into the blackboard put the destination. Before testing, be sure to go into the context and set it back to AIC enemy base. Compile and save. You can comment it to test. You can go back into the level. You can delete the new blueprint that you just dropped. Now, if we take the gray tank, put it here and play, it will do all the EQS we wanted to do. Now, he tried to retreat because he have no bullets. He have another one bullet. He tried to shoot me. Retreat, go into a good chase, and shoot. As you can see, he go to the position and then go to the shoot targets mode. So to do this, we want to create a self-abort. This self-abort will make that if the line of sight is good, called 𝗥𝗘𝗙𝗘𝗦 Boolean, it will automatically change even if the move to is running. So now, when we play, directly he saw us, he is shooting. And now, as you can see, he tried to retreat, strafe, and shoot. And voila, guys, we did it! But now, as I told, the brown enemy will do the same as the gray. But I think this episode is already really long, so we're gonna make it in the next episode. So guys, in the next episode, we're gonna fix the brown tank, so it can't move and it depends of behavior tree of the tank enemy master. We're gonna so create the behavior tree of the brown tank and try to enhance the gray tank behavior tree, especially for the focus target and the cannon 𝗥𝗘𝗙𝗙𝗦. So, thank you guys for following this tutorial. I hope you liked it and you learned a lot. If you have some question, you can join the Discord directly into the description. And if you want to support me, you can go to my Patreon to support me. It will help me a lot. And all the subscribers gonna be shown at the end of the video. Thank you guys. See you next week for the next episode. Good day to you guys. See you next time. See you next tutorials. Bye bye.